Measurement of electric current. Multimeter used as an ammeter. So we measure an electric current by using the shown multimeter aside, which is used an ammeter by adjusting it on the right scale. It is connected in series. It has two terminals, a positive terminal and a negative terminal. The positive terminal is called the A terminal, while the negative terminal is called the COM terminal. The symbol of an ammeter used in order to represent it in a certain circuit is a circle with a capital A inside, and it is necessary to show the COM terminal. Choosing the convenient scale. The chosen scale represents the maximum value of the current intensity that can be measured or read by the ammeter. Remark: the most convenient scale must be equal or slightly greater than the measured current. So when I set the ammeter on a scale of 20 milliampere, this means that it can read the currents of 20 milliampere and below. So if the current was of an intensity greater than that, the screen of the multimeter will show an error. Unit conversion. Ampere to milliampere, we have to multiply by 1000, and from milliampere to ampere we have to divide by 1000. Another unit is the microampere. It's a very small unit, smaller than milliampere by 1000 times. That's why when we convert from milliampere to microampere we have to multiply by 1000, and from microampere to milliampere we have to divide by 1000. The symbol of micro is shown here. This is, for example, is 2000 microampere. And to convert from ampere to microampere directly, we have to multiply by 10 power 6, or in other words, we have to multiply by million. Direct application. Choose the most convenient scale in the following case. Measuring a current of intensity 8 ampere. In the above remark, we said that the most convenient scale must be equal or slightly greater than the measured current. So that's why if we have 2000 microampere here as an option, and 20 milliampere, and 200 milliampere, and 10 ampere, as you can see on the multimeter aside. So to choose the most convenient one, we have to be able to, in the first step, to convert all of the given scales into the same unit to be able to compare them, or to be able to compare them to the measured current. From microampere to ampere, we have to divide by 10 power 6. It's 0.002 ampere. From milliampere to ampere, we have to divide by 10 power 3. So we obtain 0.02 ampere. Again, from milliampere to ampere, we have to divide by 10 power 3. So it's going to be 0.2 ampere. 10 ampere is already in ampere, just like the measured current, which is 8 ampere. So it's 10 ampere. Now let's check among these four ones: 0.002 ampere, 0.02 ampere, 0.2 ampere, and 10 ampere. Which one is equal or slightly greater than 8 ampere? So for sure we have that 10 ampere is slightly greater than 8 ampere. So in our case, 10 ampere is the most convenient one because it's slightly greater than it. And here I would like to mention something, which is that concerning the direct current, we have this range for direct current. When it shows a straight line here, this means that it is used for measuring the intensity of a direct current. Now book page 94, exercise 4, complete, copy and complete. 1 ampere to milliampere, we have to multiply by 1000, so we have it 1000 milliampere. From milliampere to ampere, we have to divide by 1000. Now 100 divided by 1000, we move the decimal point backwards by 3 digits. 1, 2, 3, 0.1 ampere. 0.005 ampere to milliampere. To convert from ampere to milliampere, we have to multiply by 1000. So we have to move the decimal point by 3 digits forward. 1, 2, 3. So it's 5 milliampere. 5,000 milliampere. We have to convert from milliampere to ampere by dividing by 1000. This means that we have to move the decimal point backwards by 3 digits. So if we suppose that it is 5000.00, so we have to move the decimal point here backwards 1, 2, 3 digits. So we get 5 ampere. Now the sign of the reading indicated by the ammeter depends on the connection of its COM terminal. That's why I mentioned before that it is necessary to show the COM terminal when representing the connections in an electric circuit. So sometimes we may obtain a positive reading. This is when the COM terminal of the ammeter is connected to the negative terminal of the battery. The reading indicated by the ammeter is positive. So as you can see here, the COM terminal is connected from the side of the negative terminal of the battery. Though it's not connected directly, this is not the point here whether it's connected directly or not, or whether there is an electric component in between them. But finally, the COM terminal is connected from the negative side of the battery, and the other one here is the A terminal of the ammeter is connected to the positive. So here when we have positive and negative connected to each other, then the reading is positive. Negative reading. So when the COM terminal of the ammeter is connected to the positive terminal of the battery, the reading indicated by the ammeter is negative. So we have that the COM terminal here is connected to the positive, while the other terminal, which is not shown, and it is not necessary to show the A terminal, it's enough to show the COM terminal. So here the A terminal is connected, or the positive terminal of the ammeter is connected to the negative terminal of the battery, and the COM is connected to the positive. So we have positive to negative. That's why the reading is negative. Exercise. In a closed electric circuit, the current passes from the positive pole of the dry cell to the negative pole. We measure the current with a multimeter used as an ammeter that is connected in series in the circuit. The unit of the current in SI is ampere, and its symbol is capital A. Now it is required to measure the current in a lamp using a multimeter. So it is required to measure the current in a lamp using a multimeter. Is the multimeter used as an ammeter or as a voltmeter? For sure, as long as we want to use it for measuring a current, then it is used as an ammeter. Add to the circuit of the figure 8 the multimeter in the proper connection and show the direction of the current. So as you can see here, the current comes out of the positive terminal of the battery to the negative terminal, and the ammeter is connected in series. What do I mean by series? The COM terminal, here we have one terminal of the ammeter directly connected to the negative terminal, while the other terminal of the ammeter isn't directly connected to a positive terminal of the battery. There is an electric component, which is the lamp here, in between. So that's why we consider that the ammeter is connected in series. And the third objective here is that we are showing that the COM is connected to the negative. So when we have negative connected to a negative terminal, then we obtain a positive reading. So exercise 6, page 95. Indicate the figure showing the correct connection of an ammeter indicating a positive value and justify your answer. So there are two things that we have to check when connecting an ammeter. It must be in series, and we have to check the COM terminal connection in order to check whether it gives positive reading or negative reading. In this case, we are looking for a positive reading. So let's start by elimination. Concerning series, the figure 9C doesn't show a series grouping because the COM terminal of the ammeter is connected to one terminal of the lamp and the other terminal. So for figure 9C, the ammeter is connected in parallel, not in series. Why? Because not only one terminal of the ammeter is connected to one terminal of the lamp. We have both terminals of the ammeter are connected to both terminals of the lamp. So the COM is connected directly to this terminal, which is the negative terminal of the lamp, and the positive terminal of the ammeter, which is the A terminal, is connected to the positive terminal of the lamp. So this one is eliminated. Now we still have figure 9A and figure 9B. Both figure 9A and B, show a series connection for the ammeter because only one terminal of the ammeter is connected in series with the lamp. So only one terminal of the ammeter is connected to one terminal of the lamp. Now we are left with checking the connection of the COM terminal to, to check whether it's going to give us or to indicate a positive reading. For us to obtain a positive reading, we shall have the COM terminal of the ammeter connected to the negative terminal of the battery indirectly, not necessarily directly. So which one here shows the case? It is figure 9B. So the COM is connected to the negative terminal of the battery. So that's why the correct one is 9B. So let's read now the discussion for each one. 9A, not correct since the COM terminal of the ammeter is connected to the positive terminal of the battery, and in this case the ammeter indicates a negative value. 9B is not correct since the ammeter is connected in parallel to the lamp, and in this case the ammeter acts as a short circuit and may cause fire. 9C is the correct one since the ammeter is connected in series to the lamp and the COM terminal of the ammeter is connected to the negative terminal of the battery. So in this case, we're going to obtain a positive reading.